Okay, so for this one here, is this a projected at an angle or projected horizontally question? It's horizontally, yeah. It rolls off of the table or cliff there, whatever it is, table it says. Okay, so it rolls off the table. That means it's rolling horizontally. Okay, and the table is 1.2 meters tall. Okay, the ball is going to land 0.85 meters from the base of the table. Okay, we're looking for the speed it rolled off at. Okay, which is also a horizontal value. Okay, so what we know vertically is that VI is 0 because it rolled off horizontally. Acceleration is negative 9.81 meters per second squared. And the vertical displacement is 1.2 meters, also down. Don't have to have it negative in this one because it doesn't actually change direction. Okay, horizontally, we are being asked to calculate the speed, and we know the distance traveled, 0.85 meters. Okay, and that's all we know. If I want to get V, what do I need? Time, okay, which is like what we always have to calculate in a projectile motion problem. All right, so can I find time with the vertical information? I have to, right? I don't have enough information with the horizontal to get it. So same formula we always use. Okay, 1/2 AT squared. This is 0. So T will equal the square root of D over half of A. Okay, and when we plug in our numbers here, T is going to equal the square root of 1.2 divided by 1/2 times 9.81. So it's not going to be a very long time because we're talking about only falling 1.2 meters. So square root of 1.2 divided by half of 9.81, 4.905. All right, so this thing's falling for just slightly less than half a second. All right, now that I know that time, I can put it over here, 0.49 seconds. V equals D over T. Okay. 0.85 meters divided by 0.49 seconds, okay, will get me my speed it rolled off at. So 0.85 divided by that number. All right, so we're looking at 1.7. We only have 2 significant digits, so 1.7 meters per second. Okay, how are we feeling about the horizontal ones? Okay. Are they all pretty much the same? You're either getting enough horizontal information to get time or enough vertical information to get time and then using it on the other side. Okay? The horizontal ones are pretty straightforward. At the end of the day yesterday, we started looking at some of the angled ones. Okay, so let's see what we remember from the angled ones. Okay, with this question here, I have a cannonball fired at an angle of 40 degrees above the horizontal at 140 meters per second. How far does it travel? What's its maximum height? We did 2 of these yesterday. Okay, just like this one. So you're looking at this as your start. All right, what we have to remember here is the same thing we remember for all projectile motion problems. There is a vertical component and a horizontal component. Okay? When I look at this projected velocity, this is how fast it is moving 40 degrees above the horizontal. That number is not vertical. That number is not horizontal. But parts of it are. That would be this part would be my horizontal velocity, which is constant, okay, and will stay at that value for the entire trip, as well as this side here being VI vertical, because that would be the component of that 140 that is pointed straight up at time 0, right? So if I can find those 2 sides, that gives me other pieces of information that might prove useful. so for the rest of the vertical information, okay, we have to assume, because we're not told otherwise, that the launch and impact points are level, which means our total displacement vertically is 0 over the whole trip. That won't be true when we do the maximum height. Obviously, the displacement won't be 0 there, but that's half the trip. We're dealing with the whole trip right now. Okay, so first thing I need to calculate is VI, which is the opposite side of this triangle here. So I would go sine of 40 degrees times 140 meters per second. Okay, that will give me the initial vertical velocity of the cannonball. Okay, so the initial vertical velocity of the cannonball is 89.99 meters per second up. So I'm just going to make that positive. Since the launch point and impact point are level and my total displacement is 0, what is my final velocity vertical? Negative 89.9. Right? Because what goes up must come down. And if it's coming down to the same height, it has to be going the same speed it left at, because everything else is also the same. Okay? If it starts at 89.9, it's going to reach a height, a maximum height, and at that point be a velocity of 0, and then it's going to fall from 0 back down exactly the same distance. It has to get back to the same speed it started from. Okay? So I know that VF is negative 89.99 meters per second. All right, if I have VI, VF, and A, what can I calculate that I always need in a projectile question? Time. Okay, so I would use my good old Science 10 formula, VF minus VI, okay, in this case over A to solve for T. So that would be negative 89.99 minus 89.99 divided by negative 9.81. So since negative 89.99 minus 89.99 is 89.99 times 2, I'm just going to do that as a shortcut. Hope everyone's okay with that. Okay, now I'm going to divide that by 9.81, imagining those are both negative. Okay, cannonball's in the air for 18.35 seconds. Okay, is that a long time? Pretty long time. Okay, so 18.35. Okay, can that go over here to the horizontal information? Okay. All right, I still haven't calculated the horizontal component of that launch velocity of 140. So I got to find this side of the triangle. It's the adjacent side, so I'm going to go cos of 40 times 140. Okay, which is going to give me 107.25 meters per second. Okay, so if horizontally it's going at 107 meters per second, and it does that for 18.35 seconds, can I figure out how far it goes horizontally? In other words, where it's going to hit the ground. D equals V times T. All right, so for that, okay, we just multiply those two numbers that are already in our calculator. Okay, that one times that one. Okay. Well, we only have 2 significant digits in this question, so according to this, the cannonball flies 2.0 times 10 to the 3 meters, or 2 kilometers, which is pretty far. Is it okay if I write it as 2 kilometers? It is. That's got 2 significant digits, but I could just as easily write 2.0 times 10 to the 3 meters. That's the same thing. Okay. All right. The other part of that question is calculate the maximum height. Okay, at the maximum height, one of the things I have, actually 2 of the things I have here change. What 2 things?
The final velocity.
The final velocity, okay, because here, what's VF? 0. And what else changes? when does this occur? In the middle. So how much time will have passed? Half of that total time that I have there on the board. So this number and this number change when I'm talking about halfway through the trip instead of the whole trip. Okay? So two ways to calculate this. They'll arrive at the same answer. Okay? I can use this formula. VF squared equals VI squared plus 2AD and solve for D, because the vertical displacement would be my maximum height. Okay, so that would mean going VF squared minus VI squared over 2A. Okay, when I plug in those numbers, that's 0 squared minus 89.99 squared divided by 2 times negative 9.81. Okay, so if I take that number up there, squared, and divide that by 19.62. Okay, it's going to reach a maximum height of 412, well, 413 meters. We only have two significant digits, so 4.1 times 10 to the 2 meters. Now, the other way to do this, equally valid, okay, is to use this formula. As long as I use what for the time? Half of this. Okay? So, I'm going to take that number right now and divide it by 2, so I have it. All right, so now that I've got that number, okay, now I'm going to plug in my numbers here. So I'm going to have 89.9 times whatever, the 18.35, so like 9.17 or something. 9.175, okay, plus 1/2 times negative 9.81 times 9.17 squared. Okay, now, this is a perfectly valid way to do this. I only ever show it done this way. If I'm doing one of these questions myself, like I'm making up a key for a test, I never use this method. Why? I never use this method because I make the same mistake people make when they use this method. I forget to divide the time by 2, and I forget to make 9.81 negative. Okay, those are the two most common mistakes using this method. The most common though is forgetting about the time part. Okay, I don't know how often I see people use this method with 18.35 seconds with the full time. Okay. If I do it this way though, I will get the right answer. Okay, if I take my 89.99 multiply by that half the time, okay, plus 0.5 times negative 9.81 times that number again, squared. Look at that. Down to the last decimal place, the same answer. Okay, either way is perfectly valid. The maximum height of that object, that cannonball, is going to be 4.1 times 10 to the 2 meters. That was a unit exam question. And I fear change. Okay. This one's going to work a little bit differently. I don't give you the angle on this one. On this one you have to find the angle. So you're almost going to work backwards from the other three that we've done. Okay, so still draw it out, still write out your givens, but know that you're working backwards to find the angle at which this thing is thrown. Okay guys, just in case you're stuck, okay, little push here in case you're stuck. So we know that the object is going to do this, okay, and we know that horizontally it travels 70 meters. Okay, and that it is in the air for 2.5 seconds. That's like the most incredibly useful piece of information they could give us because I get to use it in 2 different places. Okay, and it's thrown into the air at a velocity of 35 meters per second. All right, so I want to find this angle here. I know the hypotenuse is 35. I only need one more side, and I've got what I need to get that angle. Would you agree? Okay, which side can I find really quickly? Yeah, the horizontal side, because I know D and T, right? It'd be easy to get V horizontal, okay, which is right here. Then I would know two sides of that triangle. Okay, so D over T, 70 over 2.5 will give me that side of the triangle. Okay, so now I know the adjacent side. Can I get the angle now? What trait function should I use? I know the adjacent side and the hypotenuse I should use. Cosine, yeah. Okay, so if I know those two sides, okay, theta will be cos to the -1 of the adjacent side, 28, over the hypotenuse, 35. Okay, so the angle's 37 degrees. All right, now that question, is that pretty short? I mean, once you figure out what to do. You only have to do 2 calculations for that. Okay, so probably not an exam question, just because it's so short, but that could easily be a quiz question, okay, because it makes you think. Right? It's outside the box, okay, of what we've been doing, okay, just a little bit different. Okay, this one is tricky. Short, but tricky. Okay? And I will tell you, it's a bit of an algebra trick. Okay? Algebra, once you've figured out what to do, it's an algebra trick. So there's a fair amount of like, I understand how projectile motion works that goes into this one. Okay? And I will tell you that the launch point and impact point are level. Okay? So the overall vertical displacement is 0. Vertical displacement. This one's tricky. Okay? So we know that this is what's going on. Okay? It's gonna follow that projectile arc that every other one we've gone over does. Okay? What I'm looking for is this value and this angle. If I'm going to get those two things, I need two sides of the triangle. Would you agree? Okay. So I need V horizontal, and I need VI vertical. Okay. So horizontally, it tells me that it travels 30 meters in 10 seconds. Which means that 10 seconds can also be used over here, along with this number. All right, what can I calculate right now with the horizontal information? Right, I can calculate the horizontal component of the number they want me to get. Okay, so V horizontal, which will be the adjacent side, is going to be 30 over 10, which is 3 meters per second. So I know this side is 3 meters per second. All right, and that's usually where people stall. It's like, I only have 2 pieces of information vertically. I can't go any further. Except you can. There's kind of 2 ways you could go about this. Okay? Actually, only one way. That's it. One way. If the launch point and impact point are level, what do I know about VI and VF? they're the same number, opposite direction, but same magnitude, and that's important. Okay? If I know they're the same magnitude, rather than writing this out, which is probably what most people got to, and then they go, I only have 2 out of the 4 numbers. Actually, you have 2 out of 3 numbers. Because VF is equal to negative VI. So what this really could be written as is negative V minus V over T. They're the same number, opposite direction. What's negative V minus V? If I'm already negative V and I subtract another V, I'm negative 2V. Okay? Right? Negative 1 minus 1 is negative 2. So negative V minus V is negative 2V. Everyone okay with that idea? It's an algebra trick. Okay? That's what I was saying. This question is really an algebra trick. So I know that A equals negative 2V over T. Can I isolate V? I know A is 9.81. I know T is 10 seconds. Right? So now I can isolate V. So A times T equals negative 2V. Divide both sides by negative 2. And I've got that side of the triangle now. Okay? So negative 9.81 times 10 divided by negative 2. Okay? Should give me 49.05. Yeah, right? Yes, that should. I'll punch it. You guys are looking at me like I'm speaking Greek. Okay, so negative 9.81 times 10 seconds divided by negative 2. 49.05. Okay, so now I know this triangle has a 3 here and a 49.05 here. So did I draw that very well? But I didn't know that when I started it, okay, that one of these sides was going to be way bigger than the other. I just drew the general idea. Okay, now I can get that angle because I know the opposite side and the adjacent side. Is it going to be pretty steep? Very. So that angle is going to be 10 to the minus 1 of the opposite side over the adjacent side. Okay, 87 degrees, so almost vertical, okay? And I also need the magnitude, right? It asks what velocity it's being thrown at. So now I have the direction for the velocity. How do I get the magnitude?
A squared plus B squared plus C squared.
Exactly, use Pythagorean theorem. Okay, so 3 squared plus 49.05 squared gives us 49.1. Right? I mean, that triangle is so steep that there's almost no difference between the opposite side and the hypotenuse because it's just so steep. So our final answer is 49 meters per second at 87 degrees, okay, above the horizontal. Okay, that tricky one? I would never give you one like that on a test. Okay, but it's good to make you think a little bit. Okay, something like this tests your understanding. The understanding part of that is knowing the relationship between VI and VF. Okay, in a situation like this. The rest of it is admittedly a math trick. Okay, but before you get to the math trick, you had to understand that those two numbers were equal. All right, well, let's watch another terrible physics video. Okay, so on horizontal one here, objects thrown horizontally at a velocity of 10 meters per second. Okay, so we know that value from the top of a 90-meter building. Okay, we're looking for the distance, okay, along the ground, so the horizontal distance from the base of the building that the object hits the ground, right? So vertically, as always, the big thing to remember there is that initially it was not moving vertically, okay? That the acceleration is 9.81 meters per second squared, that the displacement is 90 meters, okay? And we can calculate time, square root of, okay, d over half of a. Okay, so we know the time is 4.3 seconds. Right, then we can go d equals v times t. Okay, 10 times 4.3. Okay, this is 42.8. Actually, we should only have, it should be 43, not 42.8, because there's only 2 significant digits in that question right there. Okay, want to away with that one? Okay. You have a quiz tomorrow. Tomorrow's Thursday. What do you suppose is going to be on? Yep, this for sure. Okay? So I will post something at the end of the day for you to try tonight. Also remember, guys, your vector assignments, okay? Those are coming up due here on Friday. I know a few people have them done. And I've already handed them in. If you're done and you just don't want to lose it and you want to put that responsibility on me, you can hand it in early. Okay, I will take it. Oh, you know what, Brock? I don't think you were here.